Hello and welcome to my channel, and as you all know, we are doing the problems and we have already covered 10 problems in this series which encompass various topics like resonating structures, aromaticity, carbocations, carbene ions, acidity, basicity. Basically we are covering the problems on general organic chemistry. So let us try to see what is there in our problem number 11. So as you all can see the problem on your screen, we have a compound. As you can see on the right hand side of the screen, it contains 5 hydrogens under the name A, B, C, D and E. Okay, you have to arrange these hydrogens in decreasing order of their acidity, and as I have already explained you how to decide about their acidity, you have to take these hydrogen one by one out of the carbon from where, or the atoms from where they are attached, and it will leave a minus charge on the atom where they were attached earlier. That means you are going to get a conjugate base. You are going to get an anion. Okay, so you have to take the hydrogen out and you will be getting an anion, a conjugate base, what you call it as. Now then you have to see the stability of all the conjugate bases, the anions you are going to get. You have to do this one by one, and we will take up from the hydrogen number A. Okay, so let us start from hydrogen number A. So as you all can see, the hydrogen which was connected at this carbon is now taken away as H plus. It leaves a negative charge on this carbon. Okay, and we have to assess its stability, and as you all know, the charges are symbol of burden, problem, and you have to take care of those charges. As you get this minus charge on this carbon, it is a burden on this carbon. And what is the way you can stabilize, you can reduce the burden, is by delocalizing the charge. Either it be the plus charge or a minus charge. So what are the tools of delocalizing charges? The basic and very important tools are resonance and inductive effect, out of which the resonance is a very prominent and important effect. So if you try to see whether this minus charge is in conjugation or not for resonance to happen, you find that there is no possibility. How? You can see minus, single, single. Now this is not a condition of resonance, and this minus charge is therefore not in conjugation. So it will remain localized at this carbon itself, and therefore it is a symbol of instability. You should understand, because if there was a possibility of conjugation, if there was a possibility of resonance, then this minus charge could have gone to different places, and therefore the dispersal of charge would have happened, the delocalization of charge would have happened, and that would have increased the stability of this anion. But at present you don't see any conjugation. Okay, now let us try to take away the hydrogen number B. So hydrogen number B was basically attached at this carbon. We have taken that hydrogen away as H plus, leaving behind a minus charge on this carbon. Now we will have to see that is there any possibility we can delocalize this minus charge, and because the possibility has to be seen if conjugation is present. Now if you see minus charge, single bond, double bond, from this you are now confirmed that there is a conjugation and resonance will happen, delocalization of the charge will happen, and it will increase the stability of this anion, and therefore the acidity will increase due to this stability. Now if you try to do the resonance as you all have been doing, you understand you have to take this minus charge and you have to flow it like this, there will be a new pi bond now, and simultaneously this pi bond is going to sit over this carbon, and this will get a minus charge. So in the structure, in the next structure, you can see it happening. A new pi bond has been created. This pi bond is now sitting on this carbon, and it is reflected by a presence of lone pair and a minus charge. So you see there is a possibility of delocalization which increases the stability of the anion. And you should understand, higher the stability of the anion which is formed after the proton goes away, more will be the tendency of that hydrogen to go away as H plus to show its acidity. So acidity is directly proportional to the stability of the anion you form after the removal of H as H plus. Okay, that you should understand, and that is taken care by a very important effect called as resonance. Okay, for that you have to see if at all there is any possibility or not. Now coming on to the hydrogen number C. So as you all know, the hydrogen C was attached at this carbon. So you have taken that hydrogen away, and it leaves behind a minus charge on this carbon, and now you have to look towards the stability of this anion, and that is taken into consideration, that is taken care prominently by resonance effect, if at all it is present. For that you have to check the conjugation, and as you have seen, this minus charge remains in conjugation. How? Minus, single, double. Okay, so you have to do the resonance. So I have flowed the lone pair one position ahead, and as you make this one position ahead, a new pi bond is created, and simultaneously these pi electron will sit on this carbon as a lone pair, and a minus charge will arrive at that carbon. So this structure I have drawn after this, so you can easily see that a double bond, a new pi bond has been created, and this particular carbon has now got a lone pair and a negative charge. Now you should understand, is there any possibility still left with this negative charge for resonance to happen? You have found yes. How? You see, minus charge, single bond, double bond. So there is a possibility, and therefore you should delocalize it further using that possibility, and it goes like this and makes a new pi bond there, and this pi bond simultaneously shifts on the oxygen. So you see, a new pi bond has been created, and oxygen now gets a minus charge and a lone pair. So you have seen, after taking the hydrogen number C out as H plus, an anion has been formed. Okay, this anion was seen whether it is stable or not. To judge that, the resonance was a prominent effect, and you found that there is a possibility of resonance. How? Because of conjugation, minus, single, double. And after one resonating structure you drew, there was again a possibility of delocalization, and altogether you have created 3 resonating structures. Out of these 3 resonating structures, you should understand the last structure, this one, is the most stable structure. You should understand, in all the videos I have been talking about, that minus charge is a burden. Minus charge is if it is borne by, if it is carried by a stronger atom which is more electronegative, like oxygen, like nitrogen, then it is then it feels stability. Okay, but if it is borne by a less electronegative element like carbon, is not that stable. So if you see the structure number 1, the minus was borne by a carbon. If you see the structure number 2, again the minus was borne by a carbon. But in the structure number 3, it is held by a very strong, very electronegative oxygen. So the third structure is very important and most important structure. Okay. Now coming on to the hydrogen number D. So you understand, with this hydrogen, with this carbon, the hydrogen was attached. We have taken that out as H plus, leaving behind a lone pair and a minus charge on this carbon. Now you have to see whether this minus charge is stabilized through resonance or not. Then you found that, oh, there is a presence of conjugation. How? Minus single double, and because of that a resonating structure will be formed. How? You have to delocalize these electrons to make a new pi bond, and simultaneously these pi bond will be sitting on this oxygen, and you will get a lone pair and a minus charge right over this oxygen, and a new pi bond is also seen. Okay, so you see the two structures. Okay, and from our previous discussion you have already seen that the two structures are not of the same stability. The structure number 1, the minus is borne by carbon, while the structure number 2, the minus is borne by more stronger, more electronegative oxygen, and that is a good symptom for the stability of this carbene, this anion. Okay, so structure 2 is better than structure 1. In the final slide, we are going to take all the 5 options. We will compare their merits, demerits, and then we'll decide about a final hierarchy. Now coming on to the hydrogen number E, and as you all can understand, the E hydrogen was attached with this carbon. Okay, so you have taken that hydrogen away and a minus charge now comes. The moment this minus charge comes, you find something very unusual you have got. You have a cyclic ring in this system. All the atoms are sp2 hybridized. This cycle is flat and it has a cyclic conjugation. How? Let us see. Minus, single, double, single, double. So in this conjugation song, you have included all the 5 atoms of the ring. And if you talk about whether the Huckel's rule is followed or not, let us first count the number of electrons. 2 to 4 and to 6. So you know 6 pi electron, it may be 2 pi electrons, it may be 10 pi electrons, it may be 14 pi electrons, it may be. It has to follow 4n plus 2 rule, where n can be 0, it can be 1, it can be 2. So if you put n is equal to 1, you get the 6 pi electrons, which is required by the Huckel's rule for a species to be aromatic in character. So you found a very unusual stabilizing factor associated with this anion, and that is aromatic behavior. It is aromatic. So if you will do draw the resonating structures, you will get 5 structures. Just the minus charge delocalizing, keep on delocalizing in the ring. Okay, but apart from that, it has aromaticity. From there you will get 5 structure. Apart from that, you will get one more structure that I have tried to show by drawing the different structures. So let us first go through all the structure, then we'll come to what is that structure I am telling about. Now you do the resonance, this is minus, then you can delocalize it like this, and this will come like this. Okay, so once you do this, you understand, from here you reach here, a new pi bond has came, the minus charge now comes on this carbon. Again there is a possibility you delocalize it like this, and these pi electron will sit on this carbon. So a new pi bond will come here, so you understand a new pi bond has came, and these pi electron will sit on this carbon, so a lone pair will come, a minus charge will come. Again there is a possibility of conjugation, minus, single, double. So you have to delocalize it like this, and these will come like this, and now the minus charge will come on this carbon. Now you have 2 possibility. Either you could go again in the ring, minus, single, double, that is also a possibility, and from there you will get the 5 structure which I was talking about. And the next possibility is, which is a very good possibility, that this minus charge goes in conjugation with the C double bond O, and that will give you a good structure. How? Minus, single, double. So you can delocalize it like this, and simultaneously the pi will go on the oxygen, and you will get this structure. So apart from the 5 resonating structures which will be responsible for giving giving the aromatic character to the species, you will get this extra structure also, which is also quite stable. Why? Because it has the minus charge on more powerful oxygen. So altogether you got 6 structures, and above all you got a very special thing called as aromatic behavior associated with this anion. So now in the final slide I have compared all the merits, demerits, whatever is present associated with A, B, C, D and E. Let us try to see all one by one. Now coming on to A. A, you saw after you remove this hydrogen, the minus sat on this carbon and there was no conjugation. Minus single single, minus single single is no conjugation, so there is no resonance stabilization. So you see it is coming with a demerit, the delocalization not present. Now if you remove B hydrogen, the minus came here and it was in conjugation, minus single double. So you saw the 2 resonating structures. So 2 resonating structures you got, and both the structures had minus charge on carbon. Okay. Now coming on to the C hydrogen, this is C hydrogen. Once you remove this, a minus charge comes here and you find a resonance conjugation minus single double. So a minus will come now here, and again there is a possibility minus single double. So finally the minus will come on oxygen. So if you draw all these things, you will get 3 resonating structures, and out of which 2 will be having minus on carbon and 1 will have the minus on oxygen. That is the edge this C anion will have over A and B, because it has resonance also, more number of resonance also, and one very prominent structure having minus charge on oxygen, more powerful, more able atom. Now coming on to D, you understand this is D. Again the minus will come here, and as minus comes here, you again find a conjugation minus single double. So you will get 2 resonating structures, so it will have 2 resonating structure. One, there will be minus on this carbon, another the minus will be on oxygen. So one will have the minus on carbon, the next will have the minus on oxygen. Now coming on to E, you know it's a superlative one. It has got aromatic character. After you have removed this hydrogen, the aromaticity comes to the anion, and that gives it a huge benefit. Okay, then after you have seen all these things, then you are in position to put a hierarchy, and I am putting that hierarchy. So E is the best one. So from E, the hydrogen will go away with most tendency, because it knows that the anion will take care of itself to the most extent. Okay, after E will be the number of C, because it has 3 resonating structures, out of which one is having minus on oxygen. Then will come C. After that, if you see the B and D, so both have got 2 resonating structure. In that sense, there is a tie. But the tiebreaker is, in D you have 1 minus on carbon and 1 minus on oxygen, whereas in B you had both minus charge, both resonating structures having minus charge on carbon. That is a demerit. Okay, so then will come the D, and after D will come the B, and finally you know the A is the weakest one, because there the conjugation was not seen, the resonance was not there. So again it was a beautiful problem, full of fundamentals, the conjugation, the resonance, the aromatic behavior, the acidity concept, the stability of conjugate base, and that is what I am trying to do. I want to include all the basics in my problems, and I will keep creating such type of problems in future also. I hope you all must be watching, you all must be enjoying the problems. Until then, take a good care of yourself. Thank you very much.